Okay, stars in 0, you said 1. How many stars in step 1? 3. How many stars in step 2? 5. Okay, so how many stars would be in step 3? That looks 7. That looks good. Right, and that's because as you're moving from step 2, and in this case here, step, you're adding how many stars each time? 2. Right. So then in step 3, it would be 7 stars. Okay, your initial term is, if they're giving you a drawing, it's the very first drawing. It's that initial diagram, okay? So this would be your initial term. Okay, so that means if we're using function notation, f of 0, because this is like an XY table, input, output, f of 0 is equal to 1, and so it's just 1. Okay, f of 1 gives me 3, but that's really 1, and then I add 2, and that's how I get the 3, right? You guys know this already in your head, so I'm kind of being super like elementary redundant, okay? F of 2 is equal to then that 3 plus 2, which is 5, because it's this 3, add 2. Or you could think of it as your very initial term, add 2, and that's how you're getting the 5. So they just want you guys to realize sequencing, that you like add 2. Now, I know you guys are great with this because I know that when you're stuck, I get so many tests and quizzes where on the side of the quiz or the test, you guys are doing all that arithmetic on the side and you're still getting the right answer. So I know you understand it, okay? Okay, so then f of 3 is equal to that 3 plus 2 plus 2, which is then that's your 7, okay? So 1 plus 2 plus 2 plus 2, and that's your 7. So this is like if you took it back to the first one. Okay, we do not have you guys, I don't have you write this out in a test or a quiz. It's just for those of you just to pick up on that recursive, like adding 2, okay? Okay, so then this is the part that you need. So f of n would be which step, and then n is the step, f of n is how many stars are in that step. And so if you're talking about your prior term, f of n then is f of n minus 1, I'll write it over here too, plus 2 to n plus 1. Okay. Okay, so look, you guys will get better at it, and I'll write it down here. Okay, so what this is trying, because you guys are going into sequences, when you're writing sequences, you can write it 2 ways, explicit or recursive. Recursive is what we just did right now, where if you start at the first step, which is 1 star, each time it's plus 2, plus 2, plus 2, plus 2, plus 2. So this prior term is f of n minus 1. So if I want to know what the third step is, so if I have the third drawing, how many stars are there, I look at f of n minus 1. Well, what's 3 minus 1, 2? So if I want to know what the third step, how many stars there are, I just look at the one prior and I add my 2 stars, and so 5 plus 2 is my 7, and that's how I get that. This would be your explicit, which means you have your slope-intercept form. What's my slope? 2, because that's my constant growth. That's my 2. What's my initial term? It's your y-intercept. 0, I have 1 star. 0, 1, that's your y-intercept, and so that's explicit. Okay, so now, here's a little bit of redundancy now, because we're now going to plot them. We're going to fill out this table again, which is probably what you guys, this is more like the table you would have. So this bottom part is more relatable as we move forward, okay? Okay, so if I plot the steps, this is the total stars. Because it's working, I think normally I would have broke and given you guys time. I think I'm just going to keep going with the video. and just, yeah, just, we'll see if it lasts the day, but. Okay, we're gonna plot the points. So 0, 1, 1, 3, 2, 5. Okay, but I'm gonna put them over here just so you can see it on the camera. Yeah. So plot them, right? 0, 1, 0, 1, 1, 3, 2, 5, 3, 7. Okay, do not connect the plots. Right. Because we're talking about drawings of stars, so they're not connected, because you guys don't have stars or a tenth of a star, so it's a discrete graph. Okay. Okay, all right, so here, when you look at the graph, what should you pick up? You should pick up that my y-intercept, which is the b, right, is equal to 1, because notice your y-intercept means that the graph or the function, where does it cross or touch the y-axis, right? So that's your b value. Okay, what's my slope? From point to point, what is your rise over run? I go up to right 1. And so if I'm going up to right 1, in terms of rise over run, wait, can you see it? Yeah. Okay, slope. Okay. Rise over run, if I'm going up to right 1, that's a slope of 2, which is what we got on the drawing we agreed, right? That it was +2 stars each step. Okay, if I go to the other table, then this is typically what you guys write. So if I was to give you a table, or I was to give you drawings and ask you to write it into, to fill it into the table, XY table, you guys wouldn't have a problem doing this. Okay, so then what do most of you do? You'll kind of do this arrow and you'll show your slope consistency here. And then that way you guys will see it's +2, +2, +2, and because it's a constant growth, here, let me see, constant growth, that is your slope m. So m is equal to that +2 because that's what that constant increase is. And mind you, we're talking about a linear pattern. That's what this is called, linear. So it's y = mx + b, and you'll see me write it down here. Okay, so this is what we're really working with, recursive explicit. You guys are really good with it. Once we start working with it more and more and more, you get comfortable with it. Okay, recursive. I have to dock students all the time. Even though I know you know it, students always leave it out. Okay, recursive, I need 2 things from you. I need 2 statements. One is your initial term, and this is the one that on quizzes and tests, you always leave out, even though I know you know it. Okay, what's your initial term? If I give you a table, it's your very first data point, 0, 1. F of 0 is equal to 1. Or if I'm giving you a drawing of stars, at step 0, I have 1 star. So F of 0 is equal to 1. This always gets left off. And you give me the general term. And so this one, you actually give me the hard one, and you leave off the initial one. But you guys do it every year, so it's all the same. Okay, general term is this. So if you're doing that recursive +2, +2, +2, if you want to know what term, go to the prior term, and all you do is you add that constant growth of 2. So if it was decreasing by 3, it would be minus 3. If we were doubling by 4, it would be times 4. It's that easy. Okay, explicitly, the better you are with slope-intercept form, then explicitly isn't too bad. So like here, if you understand y-intercept and slope, and you can pull it out of a graph, or you can pull it from the drawings at the top, the stars. Okay, because this is a linear pattern, and obviously I'm writing a lot because this is the first time linear, I'm spelling it wrong. That's supposed to be an I, but it's now going to look like a T. All right, pretend linear, L-I-N-E-R. Okay. Linear equation. Okay, so that's y equal mx plus b. So if you saw here from the graph, my slope is positive 2 because I go up 2 stars each time. And in the very first step, or the drawing, step 0 had 1 star, so it's just 1. That's my b value, which I have here. So okay, if you guys give me 2x plus 1, I give you perfect credit. However, we're supposed to be talking about function notation. So you can give me the n, 2n plus 1, or you can give me the x, f of x. You guys, an entire class, like this entire class, ideally it's these two, but as long as you're solving it correctly, I'm happy, and you're giving me the slope, you're giving me the y-intercept, it's fine. Whether you use the n or the x's, just as long as you know you're doing it correctly and you know how to process it, I won't criticize which of the 3 you give me. Okay. Okay, it's a 12-minute video, but it worked. So that's okay. I had to restart it a bunch of times, but I'll take it. Okay, let me